This is Math 139, Section 1.6, and we're on Part C. We've been looking at graphing quadratic functions when they're in what we had called vertex form. We could see how things were shifted, left, right, up, or down. We're now going to take a look at graphing quadratic functions that are in standard form, this form right here. You might think of it as the expanded or multiplied out form. F of x is equal to ax squared plus bx plus c, or remember that f of x is really the same as y. So we can also think of it as y equals ax squared plus bx plus c. All right, since we can't find the vertex on this one by shifting, we're going to use a formula. The vertex formula says that the x value of the vertex can be found by taking minus b over 2a. So literally just grabbing the values out of your equation and plugging them in will give you the x value. To find the y values of the vertex, we're going to take whatever our answer was, whatever our x value was, and just plug it back in for x in the original equation to find y. An easy way to say that using function notation would be to do f of negative b over 2a. But really all we're doing here is plugging this value into our function, and that's going to give us the y. All right, so let's imagine for a moment that we've got our graph over here. We've got our parabola. And what we've just decided is that we can find the vertex here as the point, the opposite of b over 2a, comma the y value, or f of the opposite of b over 2a. Next, let's take a look at the axis of symmetry. Remember, that's always the vertical line through the vertex. That's going to create, if you were to sketch it in here, create symmetry, two halves of the parabola that are the same, or reflections of one another. A vertical line always has equation x equals. And in this particular case, we know it goes through this point, which has an x value of minus b over 2a. So the equation of our axis of symmetry is just x equals minus b over 2a, the x value of the vertex. All right, the next thing that we'd like to find is the zeros or x-intercepts. In this particular case, I can see that there are two of them. To find x-intercepts, remember that you set y equal to 0. That's the same thing as saying set f of x equals 0, of course. So when I set my original equation, y or f of x equal to 0, it's going to look like this. 0 equals ax squared plus bx plus c. To solve that equation, I'll usually try factoring first, and if it doesn't factor, I'll use a quadratic formula. Finally, we have some y, or a y-intercept rather. In this particular case, it's right here. And to find the y-intercept, we just set x equal to 0, or find f of 0. Notice, by the way, that when you do that, you're going to get y equals a times 0 squared plus b times 0 plus c. So the only term that we're actually going to end up with, since that one becomes 0 and that one becomes 0, is the c. So in this case, I can actually say that the point 0c is my y-intercept. All right, one last piece of advice, and then we'll try a couple of examples. Don't forget that when you're graphing a parabola, you should always plot the vertex itself and then two additional points. We try for one on either side of the vertex. If we get into a situation where we don't have those 3 points, we may need to go ahead and get an extra point to help us out. And we'll typically use symmetry then to get the third one. We'll see that in one of our upcoming examples.